Lesson number 3. Let's talk about methods of formal proofs. Let's define an argument. An argument is a finite sequence of statements. The statements P sub 1, P sub 2, P sub 3, and so on and so forth up to P sub n are called the premises of the argument, and Q is its conclusion. So in here, an argument is equal to a paragraph. And then a proposition is equal to a sentence, specifically declarative sentence, which is either true or false. Let's say, for example, we have if P, then Q. So when I say a proposition, this one is a compound proposition. An example is, if I like you, then I will marry you. So that is just a proposition, which is compound. Okay, so how about an argument? In an argument, you have P sub 1, P sub 2, P sub 3, and so on and so forth up to P sub n. Therefore, Q. Okay, so in proposition, you just have one premise. So this P is a premise, and this Q is your conclusion. In an argument, you have not just one premise, but more than one. If in conditional, I said, if you're the one, or if I like you, then I will marry you. In an argument, I will say, or I should say, if you have car, if you're handsome, if you're loving and sweet, if you have lots of money, then I will marry you. Or therefore, I will marry you. So, ganun pag-argument. Naintindihan ba? So, marami kang premises. Hindi lang siya isa. So, let's continue. An argument is called logically valid if it is a tautology. A tautology is a statement that all the results are true. Everything is true. Example number 1. Consider the argument. If Brian solved 10 math problems correctly, then Brian obtained a grade of 1.0. Brian solved 10 math problems correctly, therefore Brian obtained a grade of 1.0. First thing first, you need to represent a proposition here. So, kailangan tayo mag-represent ng proposition. So, yung unang sentence na babasa nyo na iba or makakatayong mag-isa, you will let P. Let P be the proposition Brian solved 10 math problems correctly, and then let Q be the proposition Brian obtained a grade of 1.0. Then afterwards, what you need to do, each statement here in this given argument, you will convert into symbol. Let's say, for example, the one that I'm encircling right now, using red ink. Let us translate this one. If Brian solved 10 math problems correctly, that is your P, then Brian obtained a grade of 1.0, Q. Another statement, if we have the one that I'm encircling using green ink. Brian solved 10 math problems correctly, so that is your P, just P. And lastly, we have here color violet ink, our conclusion. Therefore, the symbol for therefore is 3 dots, like a triangle. Then, what is Brian obtained a grade of 1.0? That is Q. So, therefore, Q. Then and therefore are just the same, meaning conclusion. In our solution, as you can see, symbolizing the given argument, here are the results that I translated a while ago. So, this P and Q and this P are the premises of our given argument. And therefore, Q is our conclusion. So you can write them across. You will use the conjunction and to combine the two premises. So let's write the first premise, if P then Q, and then copy the second premise, P. Then enclose inside the brackets, therefore, Q. As it's written below, ayan nakalagay, if P then Q and P therefore Q. How to know if our given argument is valid or invalid? Let's turn back to our original given. So in here, sabi dito, pag tinagalog ko, if Brian solved 10 math problems correctly, pag nakapag-solve daw si Brian ng 10 tanong, magkakagrade daw siya ng 1. Pag sinabing 1, parang perfect 10, 100%. Okay? Then, second statement, sabi dito, Brian solved 10 math problems correctly. So, pag nakapag-solve siya ng 10, therefore, makakagrade talaga siya ng 1. So, kung susumahin mo yung ating statement, valid naman talaga. Kasi tama naman, di ba? Pag nakasolve ng 10, makakagrade ng 1. Eh, nakapag-solve siya ng 10, di makakagrade siya ng 1. But we need to prove that using a truth table. So, here. So, first thing first, let us see the first and the second column. So, we have here P in our first column. Fixed na nakalagay ito. T, T, F, F. Then, second column, true, false, pababa. And then, third column, how this happened. So, we have this conditional formula. If P, then Q. Tama ba? So, in conditional formula, we know that magkakaroon lang ng sagot ng false pag nauna true, kasunod false. So, if your premise is true and your conclusion is false, the result is false. Otherwise, true lahat ang result. So, pag may nakita kayong TF, automatically, ang sasagot nyo, false. Pag wala kayong nakitang ganon, true ang sagot. So, we will connect the first column and the second column. Just follow me. First column, true. Second column, true. Then, the result is true using conditional formula. Then, we have here T and F. Okay, TF, automatically false. And then, FT, true. FF, true. In our fourth column, you see that we have here our first premise. Our first premise can be found in the third column. And then we connected that to the first premise located in the first column using the conjunction N. So in the conjunction N, we know that magkakaroon lang tayo ng true na result pag parehas true. Otherwise, lahat ng sagot false. So, true, 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 false, 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 true, false, 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 false. Let's connect the third column to the first column using green ink. Sundan nyo yung pag-marking ko, third column. So, sabi dito, true and true. So, true. False, true, false, true, false, false, then true, false, false. Kasi isa lang yung nakita natin pattern na true, true. Kaya isa lang yung true. And then in our last column, let's erase everything. In this last column, lahat nakasulat na yung ating argument. Connected na siya, everything. How it happened, the last column. So, again, we will use conditional formula. So, in conditional, you will get false result if your hypothesis is true, followed by your conclusion, which is false. So, TF false. We will connect fourth column to second column. So, i-connect natin tong fourth column sa second column. Paano? Sundan natin basta may nabasa tayong TF, false. So, unahin natin yung fourth column. Okay? So, nakalagay dito, true, true, true. False, false, true. False, true, true. then false, false, true. So all the final results in our last column, true. So if that is all true, the argument now, we can conclude that's valid, and we call that tautology. So let's proceed to example number 2. Consider a parallel argument. If Romeo solved 6 calculus problems correctly, then Romeo obtained a grade of 2.0. Romeo obtained a grade of 2.0, therefore Romeo solved 6 calculus problems correctly. First thing first, we need to represent the proposition by variables. So let P be the proposition Romeo solved 6 calculus problems correctly, and let Q be the proposition Romeo obtained a grade of 2.0. Through this, let us translate each statement in this argument. So given this first statement that I'm encircling right now using violet ink, it says here, if Romeo solved 6 calculus problems correctly, then Romeo obtained a grade of 2.0. P, then yung sinabing then, Q. In our second statement, it says here, Romeo obtained a grade of 2.0. So what is the representation of this statement? So that is just Q. And then lastly, our therefore, Romeo solved 6 calculus problems correctly. If we translate in symbol, 3 dots, we read this therefore, and then write P. So we have two premises and 1 conclusion. So in our next slide, it appears like this downward. We can combine them together across by combining the first 2 premises. We call this premises using the conjunction N. Copy the first premise. First premise is P then Q. Then copy our second premise Q and close inside brackets. Therefore, conclusion write P. So, it is written below. Ayan. Then afterwards, you will prove that this statement, if this is valid or invalid, this argument. How to prove? Same thing in what we did in example number 1. The first and the second column, they are fixed. P, true, true, false, false. Second column, TF, TF. Then third column, applying the conditional truth table formula. So pag conditional, as you know, TF lang yung false. Otherwise, results are all true. So let's connect. Let us test. True, true, true. TF, o ayan sinasabi kong TF. So, tamang false. Then, FT, true. FF, true. Then, to get the fourth column, you will use the conjunction formula. You will connect down now the 2 premises. So, in conjunction, the result will just become true if both statements are true. Otherwise, the result will be false. Okay? So let us connect the result in our third column to our second column. So in here, marking, I will just mark it. So follow the marks. True and true, magkatabi lang sila, so true, correct. Then false and false, false, correct. True and true, so both true again, so true because of conjunction. Then true and false, false. So our fourth column now is correct. Then we will proceed to our fifth column. So in our fifth column, everything is connected now. We will connect fourth column result to first column given. using the conditional formula, if P, then Q. So, TF lang yung may resulta na false. Otherwise, pag hindi mo nakita yung TF na pattern, true. So, let's connect. True and true. Correct, this is true. False and true. True. True, false. Ayan, nakita nyo, TF yung pattern. So, false. FF, true. If you see just one false, only one false, mathematically, the whole argument is invalid. So, we will conclude now that our argument is invalid and we have a fallacy. If the argument is valid, you call that tautology, invalid argument, fallacy. We have here the rules of inference that we need to use when we prove arguments. We have here 9 formulas or 9 rules of inference. Why we call this rules of inference? Inference came from the root word infer, meaning to lead to. To lead to what? To lead to a conclusion. Okay? So why? Look at our given rules. We have here number 1, modus ponens MP, modus tollens MT. Number 3, hypothetical syllogism HS. 4th one, disjunctive syllogism DS. 5th one, constructive dilemma CD, absorption AB, simplification SIMP, conjunction conj, and addition AD. If you will notice, lahat ng ending nila natapos sa conclusion. Kung makikita niyo number 1, modus ponens, nakalagay sa dulo, therefore Q. Then number 2, therefore not P. Number 3, therefore if P, then R. Then 4, therefore Q. 5, therefore Q or S. 6, therefore if P, then P and Q. And so on and so forth. Kaya siya rules of inference. Next one. We have here now 10 rules of replacement. It came from the word replace, meaning to substitute. So all this formula you will use for substitution. Let's say for example number 1, De Morgan's. So nakalagay sa left side, sa unang formula, di ba, not P and Q. Pag dinistribute mo yung not times P, ang magiging sagot, not P. Yung nasa kanan. Then, yung symbol mababago. Yung N, naging OR na. Then, not times Q, not Q. So, if you will notice, yung nasa left side, equivalent na lang yung nasa right side. So, in our proving, pag nakita nyo nasa left, pwede nyo ipalit yung nasa right. And vice versa. Let's say, for example, number 7, material implication. If you see the formula, if P then Q, you can replace that by the right side formula, not P or Q. And also in number 6, transposition. If P then Q, meron din siyang equivalent na not Q, then not P. Ayan. So everything in this rules of replacement, they are just used for substitution. Number 2. Look at this formula, number 2. Commutative. In mathematics, when we say commutative, the order of the addends or the factors does not affect the sum or the product. So in logic, the grouping or the order of the propositions does not affect the result. So, same lang sila kahit pagbaligtarin mo. So, sa number 3, associative. Pag sinabi associative, from the word association, di ba? Associate, yun, grouping. So, the grouping of the propositions does not affect the result. Ayan. So, kung makikita mo, nalipat lang yung grouping symbol sa last 2 propositions, tapos dun sa equivalent niya sa kaliwa, sa kanan, napunta sa first 2. Pero ang symbol na ginagamit, pare-parehas, puro or. Tapos dun sa pangalawa sa babang example, lahat na ginamit, puro n. Then in distributive property, o distributive rule, so ayan yung formula. So just remember all the formulas. O double negation, example. Pag meron kang P, equal lang to sa not P. You're assuming na yung P, example 8. So ano yung mangyayari dito pag integer? So negative times negative 8, positive 8. Kaya ang sagot sa kaliwa, 8. So let us discuss the different rules of replacement. So number 1, De Morgan's. In De Morgan's, we have this formula, not P and Q is equivalent or is congruent to distribute not to each of the propositions inside the parentheses. So not times P, not P, then N will become or, not times Q, not Q. And vice versa, if I have not times P or Q, just distribute the not times P, not P. Then or will become N, not times Q, not Q. So that's it. If you see the left side, you can replace that by the right side. And if you see the right side, you can replace that by the left side. That's why we call this rule of replacement. Number 2, we have commutative. Shortcut, com. Okay, so we have this formula. If we have P and Q, it is just the same as Q and P. It means that the order of the propositions does not affect the results, even you interchange them. As well as if we have P or Q, it is just equal to Q or P. 3. Associative. So in short, ASOC. So it means from the word associate, so the grouping. So we're talking about grouping of the propositions. So we use the grouping symbol, parentheses. Let's take for example, if you have P or Q or R, it is equivalent to P or Q or R. If you notice in our left side, we group the second and the third, or the last two propositions, and on the right side, we group the first two propositions, and they are just equal. Likewise, if you have P and Q and R, it is equivalent to P and Q and R. So the grouping of the propositions does not affect the result. So at the left side, we group the last two, and at the right side, we group the first two. So that's associative. Number 4, distributive. So you will just use this when you prove. Let's recall algebra. If you have 3 times x plus 5, we will apply distributive property. So distribute 3 to each of the terms inside the parentheses. So 3 times x, 3x. Then copy the operation of plus sign. Then 3 times 5 is 15. So in mathematical logic, if you have P and Q or R, just distribute P to each of the propositions inside the parentheses. So P and Q, P and Q. Then the plus sign is like the or, is equivalent to or, then distribute P to R. P and R, so P and R. Also, if you have P or Q and R, just distribute P to each of the propositions inside again. So P or Q, P or Q, then copy the symbol N, then P or R, P or R. 5. Double negation. So in short, DN. If you have P, this is just equal to not P. It's like in integers, if you have 8, it's just the same as negative times negative 8. So negative times negative 8 will become positive 8. Number 6, transposition. In short, trans. So if you have, if P then Q, it is just equal to not Q then not P. Let's recall transposition in algebra. If you have 3x minus 4 is equal to 5, we need to solve for x. So bring down 3x, then bring down 5 at the right side of the equal sign, then transpose negative 4 to the right. So as you transpose, it will become 3x is equal to 5 plus 4. So what happened? We changed the sign. Then combine terms. So 5 plus 4 is 9. Divide the sides by 3. So cancel 3. So x now equals 3. So it means that when you transpose, you will change the sign. If that is positive, it will become negative. If that's negative, it will become positive. Number 7, material implication. When you prove, you will just write IMPL. So the formula is given by if P then Q, it is just equal to not P or Q. Okay? So if you see the left side, just replace that by the right side and vice versa. Let's say, for example, if I have if R then S, it is just the same as not R or S. So we just follow the pattern or the formula or the rule. As well as if you have if P then Q then R, it is just equal to not P, not if P then Q or R. So I will not use number 8 formula, material equivalence, and number 9 exportation in proving. So we will proceed to number 10. So in number 10, we have tautology. So just use this abbreviation, taut. If you have P, it is congruent to P or P, and also it is congruent to P and P. So if I have R, this is just equal to R or R, also equal to R and R. Rules of inference. I will discuss the last 3 rules. Number 7, simplification. Abbreviation, you will use simpt. Let's say, for example, you're in a relationship. You are P and your boyfriend or girlfriend is Q. And then your girlfriend or boyfriend leaves you or fully you. So what will gonna happen? Therefore, you will become single and forever alone. So this Q will be removed, and what's left is just P. Number 8, conjunction. Conj. So, in number 7, in simplification, you will just subtract. So, you use the symbol connective N when you want to subtract. So, in conjunction, the formula is given by, so here is you're single, and you travel, you become joiner. You meet somebody or someone, and that someone is Q. Then you talk the whole night. Then you're click. Therefore, P and Q. So you become lovers. So in conjunction, if you see a single proposition and another single proposition, you can combine them by using the symbol N. Always remember, when combining, just use the symbol N, only N. 9. Addition. Abbreviation, add. Here are you. So you're happy, you're in a relationship, but there comes a point that you're bored. So you will become two-timer. You will add another girlfriend or boyfriend. So you're a two-timer or a double crosser. So whenever you add, you will use the connective or. Always remember, in addition, just or is the symbol you're going to use when you want to add another proposition. So I will discuss now the first 3 in the rules of inference. Number 1, modus ponens. MP. So the formula is given by, if P then Q, P therefore Q. So you have 2 premises here, and this Q is your conclusion. It means that this 2 premises is equal to this one conclusion. You cannot conclude Q unless you see P, then Q, and P. Let us make an example for modus ponens. So here at our right side, you can see here a 2-column table. It's like in geometry, we have in the first column statements and in the right column reasons. As you recall, in geometry, we have encountered lots of proving in that subject when we were in junior high school. So it's like, if you have angle A is congruent to angle B, what's the reason? Diba? We will write given. So in here, numbers 1 and 2, I will write premise. It means they are just given already, no need to prove. So in here, from 3 to 6, you need to prove the following by stating the right reason. The reasons are the rules of replacement and rules of inference that I already discussed to you. So in number 3, if P then Q, what's the answer? What's the rule that we are going to apply? If you will recall the rules of replacement, you can find this number 3 in material implication formula taken from number 1. So the answer here is from number 1, IMPL, material implication. Number 4. So how we ended up with this given P and Q. As you know this, it is taken from number 2, Q and P. What's the relationship between numbers 2 and 4. The order changes. So it means we will apply the rule commutative. So from number 2, our reason here is commutative. Then, number 5. So in number 5, it just became P. So how it happened, what number it came from? It came from number 4. Because number 4, kung makikita nyo, P and Q. So P and Q, yung number 5 na isolate na lang siya, naging P na lang. So pag nababawasan, anong rule yun? Simplification. So the reason here is simp. The number 6, therefore Q. So we will prove now our given formula at the left side, modus ponens. What number it came from? 2 numbers. Let us find the premises. It came from numbers 3. Here's your number 3, P, then Q, and number 5. Reason, MP. Number 2, modus tollens. Abbreviation, MT. The formula is if P then Q, not Q, therefore not P. So we have here 2 premises, which is equal to our 1 conclusion. Let's give an example. We have here given premises numbers 1 and 2. So we need to prove from 3 to 6 by writing the correct rule taken from rules of replacement and rules of inference. So number 3, how it happened, if P then Q. So in number 3, it is taken from number 1. What rule did we apply? We apply transposition. Trans. And then number 4, if you will notice, number 4 is just the order changes. It came from number 2. So in number 2, you can see not P and not Q. In number 4, you can see not Q and not P. So they just change in terms of order. So from number 2, when we're talking about order, we are referring to commutative rule. The number 5, so not Q became isolated, just a single proposition, so it came from number 4. So we simplify number 4 by removing the proposition at the right, so we apply simp. Then number 6, proving modus tollens. At the left side, we have find the 2 premises. So the 2 premises from number 3 and number 5. Reason, modus tollens, empty. Number 3, hypothetical syllogism. HS. If we have if P then Q, if Q then R, therefore if P then R. As you notice in our given rule, it's like we can cancel Q here, applying transitive property. That is our hypothetical syllogism. Let's give an example at the right side. If I have A, if and only if B, then not T, and therefore A if and only if B, then R. So what's the missing statement at the middle or in between applying this rule? Hypothetical syllogism. As you observe our given, this A, if and only if B, is just equivalent to P taken as 1. And this not P is your Q. This one below, in our conclusion, is still equivalent to P taken as 1. And our R here is still our R in the formula. So what's the missing at the middle? So at the middle, what's missing? What's the formula here at the left? The formula here at the left is Q then R. So what is our Q? Our Q is not P. Okay? Then, what is our R? So our R is the same as R. So this is the answer. Number 4, disjunctive syllogism. Abbreviation or acronym that you're going to use when you prove DS. Given by the formula P or Q, not P, therefore Q. Let's give an example. Number 1. So we have premise number 1, not P and not Q. Then premise number 2, not Q and not P. So how we came up with number 3? How this happened? It is taken from number 1 and you applied De Morgan's. Okay, so in De Morgan's, you will just distribute the not and the symbol will be changed. If that is N, it will become OR. So for number 4, it came from number 3, double negation. So in double negation, if we have not P, that is just equal to P. So we applied double negation twice because we double negate not P becomes P and not Q becomes Q in number 4. Then number 5, it came from number 2. Just interchange or change the order. Commutative. Then number 6, so we subtracted. So it just became not P. It is taken from number 5 by simplification. 7, we will now prove our formula at the left side, disjunctive syllogism. We have 2 premises. Let's find P or Q from number 4, and then another premise, not P, and number 6, reason, DS, disjunctive syllogism. Number 5, constructive dilemma. CD. The formula is if P then Q, and if R then S, P or R, therefore Q or S. Let's give an example. This time, the statements are missing. So we need to supply the missing statements. Let's start with number 4. So it said here, the reason is from number 1, trans. So the equivalent of number 1 is if P then Q. Refer to the formula for trans in rules of replacement. Number 5, from number 2, material implication. So refer to the rule. So number 2, not R or S, is equal to if R, then S. Number 6, from numbers 4 and 5, conjunction. So when we say conjunction, we use the connective N to connect two or to combine two statements. So copy first number 4, if P then Q, then copy number 5, if R then S. Then number 7, from number 3, add. So what we're gonna add to R? So in our left side, constructive dilemma, we can just add if we're using the symbol OR. So to have P or R, we need to add P to R. So R or P. Then in here, in constructive dilemma, it's P or R. So it says in number 7, commutative. So change the order. It will become P or R. And we can prove now constructive dilemma, number 9. It's from number 6 and 8, constructive dilemma. So here is the conclusion. Therefore, Q or S. That's constructive dilemma. Number 6, absorption. Abbreviation, ABS. Given by the formula, if P then Q, therefore, if P, then P and Q. Let's give an example. Number 1, Q or not P. So that's our given premise. What is the missing statement in number 2? So it says here in our rule, from 1, commutative. What we're going to do, just interchange this number 1. It will become not P or Q. The number 3, it says here from number 2, material implication. So what's the equivalent of this in material implication formula? So the equivalent of number 2 is if P then Q. So now we can prove absorption here at the left side. So therefore, if P, then P and Q.